Probability with complements and compound events. Suppose that 36% of college graduates stay on their first full-time job less than 1 year. College graduates are randomly selected in each of the following scenarios. A, find the probability that 2 college graduates stay on their full-time job for 1 year or more. B, find the probability, before you go on and try to read everything in a probability problem, you probably want to break it down and make sure you understand the scenario first. So sometimes the hardest part with probability problems is that there's so much information. So we're going to break this problem down into its parts, but also into just the setup. So the first thing that we want to look at is just the basic information that they give us before they even post a question in a problem. So we've got that 36% of college graduates stay on their first full-time job less than 1 year. So we have an event going on here. So we're going to write down, I'm going to name that event. I'm going to let L represent the event that the graduate, I don't have much room here, so I'm going to try to shorten it. The grad will stay on the job, stays on the job, and I used L for less than 1 year. 1 year. Okay, so that's my event L, and I've been told in the problem that happens 36% of the time. So the probability of L, if I had 1 college graduate selected at random, that probability would be 0.36 or 36%. So before I move on, hopefully I can figure out that there's also another probability that I'm given without them explicitly stating it, and that's the probability of the complement. The complement of event L would be the event L bar. And for L bar, if a graduate staying on a job less than 1 year is L, the complement is going to be that the grad stays on the job for 1 year or more, or longer, all right. Does that make sense? Together, L and L bar are the only thing, are everything that can happen with this college grad's first full-time job. They will either be on less than a year or they'll stay on that job 1 year or longer. And so the probability of L bar, we know complements, the probabilities of the complement is going to be 1 minus the probability of the original event. And so that'll be 1 minus 0.36, which is 64%. So very important thing to do is before moving on to the question is kind of get all the information that you can out of the problem so that you understand the scenario. There's one more thing I'm going to do, and when I notice that in all of these problems, 2 college graduates are going to be randomly selected, I'm going to also think about my sample space. If I have 2 college graduates that are going to be selected, my sample space, what could happen? Both of those 2 college graduates could stay on the job for less than 1 year. And so in this scenario, there's an implied and. The way I write this, there's an implied and here. This means the first person stays on for less than a year and the second person stays on the job for less than a year. But what else could happen? We could also have the first person stays on for less than a year and the second one stays on their job for longer. The first one could stay on the job for a long time and the second one could leave before a year's up. And then the last scenario is where they both stay on the job. So this sample space, even though I may not use it, it helps me to understand what's happening in the problem, and I guarantee I am going to use it a little later. So a lot of information here. So now in the first scenario, again, I've got 2 college graduates and I want to know the probability that they both stay on their full-time job for 1 year or more. So first, is this having to do with the event L, which is less than 1 year, or is this the event L bar, 1 year or more? And I see that we're talking about L bar. So in my sample space, I wrote this, I have to have both of them stay on their job for 1 year or more. So I'm looking at the probability that we've got L bar and L bar. So again, remembering that in here we've got the implied and in probability, and actually is going to lead you to know that you need to multiply. So the chance that the first person stays on their job for more than 1 year, their chance is 64%. But we've now got another individual, and we want them to also stay on their job for 1 year or more. And so we've got to combine those probabilities in such a way that models this and problem. And so when I do that, I end up getting 0.4096. So there is if I round to the nearest tenth of a percent, I've got 41.0% chance that both college grads stay on their first full-time job. I hope I have enough room. Their first full-time job for 1 year or more. Just made it. Okay. Part B in this problem wants us to find the probability that exactly one of the two college graduates, again, stays on their full-time job for 1 year or more. So again, 1 year or longer is still talking about L bar, but in this case, we just want exactly one of them. So in our sample space, this would be the events if exactly one. So either the first guy will stay in for a long time and the second guy won't, or we could have the first, or guy, I guess it could be a girl too, right? College grads are girls too. I'm one. Okay, cool. Or the first college grad could be in for less than a year and the second one for longer. So notice again, now we've got a compound event with the or condition. And or in probability implies addition. So this would be, we'd break this up as the probability of L bar L, or would be addition, probability of L bar. And then again, remember the implied connector between the L bar and the L here is an and statement. So the and is going to make us have some multiplication here and then also some multiplication over here. So this would be the probability that the first person is on their job for 1 year or longer would be 0.64. So that's going to come first here, 0.64. And then the second person being, second grad being on the job for less than a year, remember that probability is over here, a 0.36. So 0.36. Then I'm going to add that to the probability that let's say it could have been the scenario where the first person was on the job less than a year, 0.36, and the second person was on the job for longer. And that comes out to, when I add all those together, I hope it did. I hope I did all my arithmetic well. I think the better you get at mathematics, the worse you get at arithmetic. So check me on this. But there is a 46.1% chance that exactly one of the two grads stays on their job on their first, I abbreviate here, a full-time job for 1 year or more. That's it. So we're working those compound events of and or. The final problem asks you to find the probability that at least one of 2 college graduates stay on their full-time job for 1 year or more. So at least, the phrases at least and at most can oftentimes signify a lot of events. Let's look back at our sample space. And our sample space was LL.